Hello everybody. So today we are continuing with multiplying polynomials, but now we're moving on to special products. So special products are just that. It's a pair of two binomials that have a special pattern. So instead of foiling, you can recognize a pattern within them. So you can always use the FOIL method to find the product, but there are some specific patterns. And these patterns will be important in understanding when we actually learn how to factor, which is going the other way. So going from expanded form back into factored form. So again, we can use these diagrams to visually think about squaring a binomial. So this is an x, and this is just 1, 1, 1. This is an x, and this is just 1, 1, 1. So this represents x plus 3 being multiplied by x plus 3. So when the x and the x are multiplied together, it creates your big x squared monster there. When an x and a 1 are multiplied together, it creates an x. So these are created here. Really beautiful drawing, Mrs. Weens. You know, I feel like I should have been an artist. Said no one ever. Okay, so here are all the x's. So there are 6 of them. And then the ones and the ones create little ones. So I could draw little boxes. There's 9 of them. I'm just going to get lazy and draw circles. These are all ones. So you can see we have x squared plus 6x plus 9. Okay, we do not have what a lot of people think, which is just x squared plus 9. A lot of people see this squared and they think, oh, I just put the square to the x and the square to the 3 and get x squared plus 9. But as you can see, that is not correct. This is correct. So again, the one way to do it is you could rewrite this as x plus 3 times x plus 3. Because x plus 3 all squared, that's what it means. It means that you're multiplying x plus 3 by itself. So when you FOIL, you will get the firsts, which is x squared. The insides is 3x. The outsides is 3x. And the lasts is 9. So this simplifies together to get x squared plus 6x plus 9. But again, there is another way of doing this without actually having to FOIL. When you're multiplying a bracket by itself, you will always get the first thing squared. And then at the end, you'll have the last thing squared. And in the middle, this is the tricky part, you will always have 2 times whatever is first times whatever is last. So let's look at this example. What's first here is x. So first squared is x squared. What's last here is 3. So last squared, 3 squared is 9. In the middle, you have 2 times x times 3. So 2 times 3x is 6x, and that's the pattern. Okay, so alternatively, you can use a pattern. So that pattern is, so here's the first. So you take the first thing squared, then you take 2 times the first and the last thing, and then you add whatever is last squared. Now, if you have a subtraction here, the only thing that changes is this sign right here. This is subtract 2ab plus b squared. Okay, in order to prove this, you can actually do the FOIL method with either one of those. So these are called perfect square binomials. Sorry, trinomials. Trinomials because they have 3 terms, and perfect square because they're the result of a perfect square. Let's do some examples. So remember, if you do get stuck, you could always do the FOIL method, remembering though that this would be x plus 4 times x plus 4. It's the bracket times itself. So it is not equal to just x squared plus 16. That is not correct. Okay, But using our special product, we can do that. So it's the first thing squared. So our first thing is x. And then 2 times this times this. So this times this is 4x times 2 is 8x. And then plus the last thing squared, so 16. Again, subtraction, the only thing that changes is that the first sign here is a subtraction instead of an addition. So the first thing squared is k squared. 2 times this product is negative 10k plus 25. Okay, the last squared. Let's do this one. Okay, the first thing squared is 9y squared. Be careful. You have to think of all of 3y being squared. Okay, 9y squared. Then 2 times this product. So 3 times 7, so 3y times 7x is 21xy. So twice that is 42xy. Then times the last thing squared, so 49x squared. Finally, we square this, 4a squared, and then we double this product. So 2a times 5 is 10a, so twice that is 20a, and then 5 squared is 25. All right, so that is what we call a perfect square trinomial. So now we're going to be moving to another pattern which shows up a lot, which is the product of a sum and a difference. So if you look at this example, you have x plus 3 and x minus 3. And if you go ahead and look what I have down here, that's what they're all like. You have plus the same thing and then subtract the same thing. So when you multiply the sum and the difference of the two terms, there are only going to be 2 terms in the simplified expansion. So before I finish this, let me show you the example. So first, x times x is x squared. Okay, now get a different color for this. We get outsides, which is negative 3x, and then insides, which is plus 3x. Okay, then we do our lasts, which is minus 9. Now, what do you notice about the terms in blue? What you should notice is that negative 3x plus 3x will cancel each other out and actually get to 0. So your result is just x squared minus 9. There's no middle term. There's no x term because they will always cancel each other out. That's because if you're adding and then subtracting the same thing, it will cancel each other out. So we can say there is no middle term or no x term because the other two products cancel each other out. So to find the product and the sum, we can use the rule. Okay, so it's always going to be just a squared minus b squared because the negative ab and the positive ba is the same thing. They cancel each other out. So the resulting product, which is just a squared minus b squared, is called the difference of squares. So let's see this in action. So x minus 11 times x plus 11. So first thing is to notice that this fits this pattern. So we could do all the way through and FOIL, but the plus 11x and the minus 11x would cancel each other out. So we don't actually need to show that. We can just go to our rule. So we just do the first term squared, which is x squared, minus the last term squared, which is 121. Let's try it again with this one. Again, we notice that we're adding and subtracting the exact same thing. So it's the first thing squared, a squared, minus the last squared, 25 squared. Here it gets a bit more complicated with coefficients. So 4m plus 3n, 4m minus 3n, if it's the pattern. So the first term squared is 16m squared. Remember to square the number. And then the second is minus 9n squared. Okay, how about you pause the video and try the next one? Okay, so there we go. Let's get to a word problem and let's see which one of these two new rules we learned it uses. The radius of a circular helicopter landing pad is increased by 3 meters. Find a simplified area expression for the area of the new circle. So the old area would be pi r squared. But our new area has a radius that's been increased by 3. So it's r plus 3 all squared. So we need to expand this bracket. So this is from the first page, okay? It's the same, it's the special product where you're squaring, the same thing. Okay, so it will create a perfect square trinomial. So remember here, we square the first product, then we add, since it's adding, double this product, so 6r, because 3r times 2 is 6r, and then we add the square of the last term. Okay, now we can simply multiply pi through, so pi r squared plus 6 pi r plus 9 pi would be a simplified expression for the area of the new circle. Okay, so those are your two special kinds of new patterns. Thanks for watching. I hope you learned lots.